The element carbon is like a treasure box. It holds various interesting mysteries. One such unique concept is that of the homologous series. What does it mean? Let's understand this in detail. Let us get to know the concept by breaking it into two parts: homologous and series. One thought we might have is that it refers to some series having similarities. Is it true? Yes, absolutely. In the first part, the word homo refers to same. So in the case of homologous series, we will have compounds that have something in common. But what is common? Here we are referring to the common functional groups. What about the next part, that is series? For being in the list of homologous series, the compounds need to occur in a sequence. That means they will occur in succession. And what do we mean by this? Let us consider the simpler alkanes like methane, ethane, propane and butane. Are they in succession? You may say yes. They occur one after the other. But what exactly makes them successive to each other? To understand this, first tell me what is the molecular formula for each. The molecular formula of methane is CH4. That's right. Ethane is C2H6 and propane is C3H8. And how is butane expressed? Its molecular formula is C4H10. Now what will happen if I add CH2 to the molecular formula of methane? It gives me C2H6, right? That is ethane. And if I add CH2 to the molecular formula of ethane, does that give me propane? Yes. Adding CH2 to the formula C2H6 gives me C3H8, which is nothing but propane. And you know the last one. Adding CH2 to propane gives us C4H10, that is butane. Now can you tell me how exactly these compounds are in series? Yes, they are in succession. And what is the common functional group among these compounds? Needless to say, it's an alkane. That means the compounds here will have the same general formula. For example, in this case, the general formula for alkanes is CnH2n plus 2. So all of these compounds show this typical general formula, right? Yes, they do. Even though they have different molecular formulae, the general formula is the same. And we also noticed a common difference between any two successive compounds. There's a common difference of CH2. Now that we've understood the concept, let's define the term homologous series in simple words. It is the series in which the compounds with the same general formula but different molecular formula occur in immediate succession. So the hydrocarbons in the homologous series will have different lengths of carbon chains, but they will possess the same functional group and will occur in succession. Now tell me one thing, if these compounds are in series with the same functional group, don't you think their properties will also be the same? Well, if you said yes, then you are apparently wrong. Because all the properties of elements in the homologous series are not exactly the same. The chemical properties are definitely similar as they are dependent on the functional group present. However, the physical properties show gradation as we go higher in the series. That's because the physical properties like the boiling point, melting point, solubility, and so on differ with the change in molecular mass. For example, a compound with 10 carbon atoms will have a higher boiling point compared to a compound with 3 carbon atoms. That's because the energy required to break the bonds will be greater. This is how compounds in the homologous series slightly differ from each other in spite of being in a sequence. This was about the concept of homologous series seen in the carbon compounds. Let's talk about another interesting concept of isomers in the next video.
In this introduction to organic chemistry, you will learn the definition of a hydrocarbon and how functional groups give molecules similar properties. Organic chemistry is the study of carbon compounds. There are many millions of organic compounds that you can make using hydrogen and carbon and arranging them in different ways. Hydrocarbons are defined as compounds made of hydrogen and carbon only. The simplest hydrocarbon is methane. It consists of one carbon with 4 covalent bonds to hydrogen atoms. The next in the series has 2 carbon atoms, and this is called ethane, and is followed by propane and then butane, these being the names of the first 4 in the series of molecules called the alkanes. Pause this video now and try to draw the structure of hexane. Hexane has 6 carbon atoms. Here is the structure of hexane. Compare it to the structure you drew. Did you get it right? The next series is called the alkenes. These are hydrocarbons that contain a double covalent bond between 2 carbon atoms in the molecule. Just like the alkanes, each carbon atom still needs 4 bonds, but has 2 bonds already due to the double covalent bond with the other carbon atoms. The ethene molecule is completed by 2 more bonds with 2 hydrogen atoms for each of the carbon atoms. These also follow a pattern, and the next molecule in the series is propene and then butene. Pause this video now and try to draw the structure of hexene. As before, hexene has 6 carbon atoms. Here is the structure of hexene. This time there is a double bond because it's an alkene. The video tutorial on the alkanes and alkenes will give you more in-depth knowledge on the bonding and structure of these series of molecules. As we have already discussed, hydrocarbons are molecules containing only carbon and hydrogen atoms. However, the study of organic chemistry includes any molecule with a carbon backbone. Functional groups are groups of atoms which give molecules similar properties. There are many different functional groups. You may have heard of the alcohol group. This is a hydroxyl group and is a hydrogen bonded to an oxygen, which is then covalently bonded to the rest of the molecule. This group can be attached to any of the alkanes to form alcohols, their name all ending in -ol. For example, methanol, ethanol, and propanol. Pause this video now and try to work out the name of this molecule. There are 4 carbon atoms in this molecule with an alcohol group, and so its name is butanol. The alcohol functional group means that all these compounds will react in a similar way and will have similar properties. Carboxylic acids are another example of a functional group. This is the functional group for a carboxylic acid and gives an organic molecule the name oic acid. Methanoic acid, ethanoic acid, propanoic acid, and butanoic acid. There are lots more functional groups. Esters, which give molecules a sweet smell and make them useful for perfumes and flavourings. Ketones, which make molecules useful as solvents. Amines, which can be used as dyes and useful in making medicines. Some molecules have more than one functional group and give molecules different properties still. Now, by the end of this video, you should know that organic chemistry is the study of carbon-based molecules, and that hydrocarbons are molecules containing hydrogen and carbon only. You should also know that functional groups are groups of atoms which give molecules similar properties.